Hello and welcome to today's SEI webcast. What are deepfakes and how can we detect them? My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make today's event as interactive as possible, so we will address questions throughout today's presentation and again at the end of the talk. You can submit those questions in the YouTube chat area now, and we will get to as many as we can. Our featured speakers today are Shannon Gallagher and Dominic Ross. Shannon is a data scientist here at the SEI, where she works on various statistical and machine learning projects. Dominic is the broadcast media design team lead here at the Software Engineering Institute, where he focuses on multimedia research and transformative gamification projects. Now I'd like to turn the presentation over to Shannon Gallagher. Shannon, welcome, all yours.
All right, thank you. Well, we said we'd answer two questions today. What are deepfakes and how can we detect them? So we'll get started. So we like to start off as make this interactive, and we would like all the viewers listening right now to, we're going to give you a little quiz. Can you spot the deepfake? And we're going to give you a hint. There is exactly one. One of these images is a deepfake. So please let us know, is it A, is it B, or is it C?
You can go ahead and put that in the chat.
Yes, please. And while those answers come in, while we're getting tabulated, we'll go through, answer the first question for you. What is a deepfake? And so this is the working definition I use, which is coming more from the sort of academic side. And I like it, though. It says a deepfake is believable media generated by a deep neural network. And this is from this Mirsky and Lee paper. But Dom and I come from different backgrounds and maybe have different definitions of deepfakes. So what do you think about this definition, Dom?
Yeah, I would definitely say that from a creative side, we kind of bifurcate this definition to distorted media and fabricated media. So distorted media is something that individuals may be aware of when they're watching a Hollywood movie, where they're seeing, computer graphics being integrated in to create an image that doesn't necessarily exist, where fabricated media is more something that would come out of a deep neural network, machine learning practice to create an object that doesn't exist.
Great. And so does anyone really care, though, whether it's made from by an artist or an algorithm, if it ends up fooling us?
No, I think as soon as somebody's fooled, they don't really care how it was made. They just care about the result.
Yes. And we do have reasons why we should care. So lately, when I've been talking to people about this project, I've been pointed to this comic from XKCD. And to give you a little summary of what's going on, the person with the hat says, "Oh no, deepfakes are a thing now. We can't trust any video, and life will become meaningless." So that's extrapolating a little bit. But the person without the hat has a nice rebuttal and says, "I don't know, Photoshop's been around for a very long time. CGI, photos have been staged. But, there's a deeper problem. People have been lying since the dawn of time. And deepfakes are really just an extension of lying. So why are we getting so concerned about it?" And I do think that to an extent that is true. But I think we still should care because deepfakes are far more accessible, they're automated and scalable at millions of hours, potentially, 100,000s of hours. So we should care.
So Shane, do we have any results to our poll?
Yeah, sorry about that, Don. We had 5 voted A, 5 voted C, and 1 for B.
Okay.
Right. So it looks like we have some pretty good deepfake spotters here. So we're curious what tipped you off, but we're going to get into some of that right now.
Yeah. So just one thing to make people aware of, they may be experiencing deepfakes without even knowing it at this point. So a great example that happened recently, Mark Hamill was recast in The Mandalorian to play essentially a young Luke Skywalker, but obviously he's aged out of the role. So what they did was they used deepfake technology to allow Mark Hamill to play the part that he was born to play, but also make it so that it's age appropriate. You're also starting to see Hollywood integrate deepfakes into audio dubbing. So movies are global. They air in multiple markets and with multiple languages. And what we're starting to see now is that original actor that was cast through synthetic voice as well as mouth manipulation, they can actually dub in that natural language for whatever that local market is and not have to worry about it seeming incorrect. So you no longer have to cast multiple individuals for the same part. And I'm sure that's probably good and bad. What do you think, Shannon?
Well, do you think it's a cost-saving mechanism?
I think it is. I think it's also a way that they can preserve a film's integrity. Often, different performances can come across wildly different in different markets, and maybe the director wanted a scene to be serious, but the audio dub performer maybe reads it a little bit more comedic, and that could be good and bad because you're kind of changing the work of art at that point. But no matter what, I guess it beats watching subtitles, right?
That's true. But deepfakes can be more than audio, right?
Yeah, I mean, well, they definitely can. So they can be audio, video, they could be still imagery. There's all kinds of different types of deepfakes on the market right now. We're going to get into synthetic voice here, though. So one of the first most famous examples of synthetic voice being used in a Hollywood production was the Anthony Bourdain documentary that came out shortly after he had passed away. And what they did was they took some notes that he had handwritten, and they trained a neural network on his voice, and they recreated that audio and then inserted it into the documentary and did not tell individuals where it happened because, to their point, they believed that you would never know. And they could enhance the story by having him read this audio. I'm sure that gets into some ethical challenges, right, Shannon?
Yes. And this case and a few others like it with the synthetic voices really made me start to pause and consider the ethical side of deepfakes. The Anthony Bourdain one, it really is only a few words here and there that have been replaced, but it's really surprising to me that less than a year later, you have that Andy Warhol deepfake video with completely new things said and just how accepted it was by the public. So it's amazing how fast technology progresses.
Yeah, the desensitization of technology itself and the willing for people to accept deepfakes is happening at a rapid pace. And you're starting to see that from a filmmaker's perspective as well. So another great example is the recent Beatles documentary where they were performing in a studio and the audio wasn't the best fidelity. So they trained neural networks on Beatles voices, and they were able to re-record those performances so that they came back with a higher fidelity audio. So just like the previous example with Mark Hamill, you're essentially de-aging an experience to enhance it for an audience and market it to people in a quality level that people would accept. But that's not always the greatest thing in the world, right? So another example that we're seeing is previous films being redone, and so CG that maybe wasn't the best quality because they didn't have the best budget, or a black and white film being recreated in color so that individuals could see it the way that they would expect to see it today. I'm sure there's some trade-offs ethically, right, Shannon?
Yes, and we see that in your last example at the bottom, right?
Oh yeah, so that's a great point. So they could be nefarious in nature. So there's a great example of a CEO being swindled over hundreds of thousands of dollars because of a synthetic voice, or potentially a synthetic voice, being used to scam them. So it's kind of like fishing to a whole new level, right?
Yeah, it's not too crazy for me to believe, if somebody calls me up on the phone, I recognize their voice, I'm probably going to trust them.
Yeah. Well, and speaking of trust, the next example as we go through a bunch of how deepfakes are used today, synthetic avatars. So Synthesia was a company that I think was an early pioneer in deepfaking. And I believe they were part of the face-to-face algorithm, but I can't confirm that. But what I can say is what you're seeing here are examples of digital humans. So it's a mixture between, synthetic voice and mouth manipulation and, artificial creation of people that don't exist. And they're being used for multiple reasons. So it could be customer support, or it could be the face of a company. Can you think of any reasons why a company would be attracted to this, Shannon?
Yeah, it's kind of interesting, but I guess, if you're, I think you mentioned that it's DE and I reasons, perhaps.
Yeah, maybe you're a technology company and your staff isn't exactly the most diverse, and you want to portray your company as a more diverse company. Well, you can kind of create your own individual. You can choose the look, the ethnicity, the color of their skin. It could be even how deep their voice is. You have total control over that. At the same time, it also can feel a little weird. I think we all, when we first came across voice assistants, maybe didn't treat them as well as we should, right, Shannon?
No, I always treated my voice assistant with utmost care. So,
well, I wasn't as respectful as you, but I can tell you this, that I think having that human face would probably sensitize me more, and maybe I may treat the technology with a little bit more respect. You notice anything else weird about these digital humans?
Yes. One thing that always strikes me about these avatars is just that they're beautiful people. Why do you think that is, Dom?
Well, there's a number of reasons I'd say. First off, we're attracted to beautiful images and beautiful people, and we kind of assign a trust factor with that as well. So as these data sets are being created, people are naturally curating the more beautiful images and putting them in. And what happens is you might create a form of bias in the algorithm itself, so that the results come in and they may actually be more beautiful than the average population, right?
Yeah, I guess, can we trust these beautiful people then?
I don't know if we could ever trust them before, Shannon, but let's keep continuing about people that don't exist, though. So this is another example. This website, this person does not exist. Do you have any experience with that?
Oh, yes. This one makes it on my bookmarks a lot. I really like it and its sister sites, which includes this room does not exist and this cat does not exist.
Oh, I don't know if I can handle the cuteness of the cats.
They're pretty cute and completely fake cats. It's wild.
Yeah. Well, so what you're seeing in the user experience domain, media research, mock-ups, you're starting to see these type of websites being integrated into the technology itself. So you can see the attractiveness for it for a designer. Essentially, you in the past, you had to go to a stock media website to get an example of an individual that you can put into a UI mockup or a website and use that for marketing material. But now you can just generate any type of human you like. And if you're not happy with them, with the click of a button, you can have another one. So it's a time saver, but it also probably helps when it comes to copyright protection over the image itself, as long as you're correctly sourcing the website, I would assume, and following the terms of services. But now we're starting to get into some more of the weird stuff, the future case. So Netflix did a documentary called The Future Of. And the very first episode centered around life after death. And what we're also starting to see now is that merger of that digital avatar with synthetic voice to be used as a manifestation of an individual after they've passed away. And the whole idea is your body is essentially buried with an organic piece of material like a tree. And that tree could potentially then power a tablet or a holographic device that then portrays a digital version of yourself in a park, so that your loved ones or even the average passerby can come and just have a conversation with you. So is this something you're going to be signing up for?
That's an emphatic no from me. Just this one I find really freaky, but it is kind of crazy. It makes me feel like we're living in a sci-fi novel or book.
Yeah, it's kind of Blade Runner, I guess. At the same time, I could see why it could appeal to some people. There's a number of individuals that keep their loved ones' messages on their cell phones long after they've passed, or they have a continent that they've always discussed life-changing, issues with, and that trusted resource that may gravitate towards being able to have that conversation with them again, even if it is a machine learning or AI algorithm that's actually behind the individual itself. So we've learned about the technologies and, what's kind of being created in the now. But we also got to think about, okay, with all this artificial media, how do we start detecting them? And I'd say the human eye is really the best way for doing it at the moment still. If it doesn't look right, chances are it's probably not right. If the head's the wrong size, or eyes are blurry and the mouth's in focus, or it looks like a bunch of different people have been composited together and it just doesn't feel right, it's probably not right. But how do we kind of extrapolate that from a data scientist point of view, Shannon?
Sure. We call them digital fingerprints for a reason. At a crime scene, you would expect fingerprints or something to be left. And we kind of expect the same thing to happen in these artificial media. We expect to find some evidence about them. And like Dom said, using your eye is usually a very good tool. And the challenge that we have is taking the artistry and transferring it to some of the algorithm. And sometimes we pose it as human versus computer, but usually, like most things, it's human and computer. But we'll start a little bit, I think, from the side that we're most familiar with, and that's using our own eyes. And you're going to talk about that, right, Dom?
Yeah, so let's talk about using our own eyes, and let's start to get into the meat of the discussion where people are going to actually learn how to spot deepfakes. And this is probably a pretty easy example that most people are familiar with on how to spot a deepfake without really knowing how to spot deepfakes, right? Is there anything on this image that really stands out to you, Shannon?
Yeah, like the first thought I have is just this looks bad, and it seems like someone just put a sticker over someone's head.
Yeah, you're absolutely correct. The other thing that should be a tip off to most people, and I call this like the low hanging fruit when you're evaluating a piece of media. This is a nation's leader, and the top of their head is cut off. And why is that happening? Well, when you train a deep neural network on how to do a whole head deepfake, and that's what this is an example of, is a whole head deepfake, and you don't set your masking parameters correctly, what happens is the algorithm doesn't know where the top of the head ends, so it just cuts it off. And because of that, they spent weeks probably training a model without the top of the head to be generated. So what are they going to do? They could either restart from the beginning, remask it correctly, or they could release their deepfake. They chose the latter. So I would say the first tip off people would say, would the president of the United States have their head chopped off when they're presenting to the nation? And I'd say probably not, right, Shannon?
It seems very unlikely.
Yeah. The other one is the focus. So we can see that the face is very blurry, and we can see the shirt is in much more focus. That's kind of an easy tip off, where the face almost looks like a painting as opposed to the body actually looking like real life. Do you see anything else, Shannon, that like really sticks out?
The other thing that sticks out to me is the color difference between the face and the neck. One seems a lot paler than the other.
You're absolutely correct, Shannon. There is definitely issues with the color in this image. So we've just by not knowing too much, we've already been able to identify multiple reasons why something like this would fail. Shannon, it looks like we may have a question in the chat, though. Shane?
Okay.
Yeah.
All right.
A question from Pi asked, could you do, or a more comment, do a covariance analysis and also assess the skew? Is that something you're familiar with?
Sure. So I think what this person is asking is, can we analyze the images and see how similar the real images are to each other, and also examine the fake images that we do know and see how those ones are all similar to each other. And we would expect the one perhaps to have different variants than the other. And yeah, that is absolutely something that one of the first steps that we take in our analysis.
Great. So we're going to get into now post-processing of a deepfake. So we looked at an example of something that came out of an algorithm that wasn't essentially good enough to fool a human eye. So how do you improve on that? And the good lesson to learn how to improve on it is it teaches us also how to better detect them. So what we're seeing here is an example of two stock images. And we talked about the definitions of deepfakes earlier. This is not going to be an example of an actual deepfake. If you want to see that, we're going to be doing deepfake days down in Arlington on the 30th. Look at the channels, reach out to the SCI for more information on that. But here we're going to give you more of a representation of how deepfakes work and how to detect them. So we're going to move through and we're going to look at what a typical result would possibly look coming out of an algorithm. So on the left here, what we see is a composited image of a source and destination. And what we're seeing is the face not having any type of color correction applied to it. Now, you can either train your model when you're creating a face replacement like this with color correction from the start, or as I would probably suggest, it's probably a better idea to do it towards the end of your model being generated. So you're actually training it on a value that you're actually going to use on an output. So if you look at the right, though, it's basically if you took that same algorithm and decided, okay, I'm going to use one of the 5 preset color corrections on here. And Shannon, what do you think? I don't think the results are bad, but I don't think they're fooling anybody, right?
No, the one on the right looks pretty good, but also something like one of those eye tests at the optometrist.
Yeah, it's like, better A or better B. They're still both bad, right? So we still got to flip to the next lens. But you can see right along the chin there, especially on the one on the right, where the discoloration occurs, would be an easy tip off for most people looking at it and being able to see that mask. But so how can we improve on that? Well, it all kind of starts with how you actually create deepfakes. And there's a lot of post-processing that happens with the algorithm, as well as if you're going to interject the art. So Shannon, can you talk to us a little bit about how the algorithm is handling this type of isolation?
Sure. And I think in both the art and the algorithm, one thing that we really need to do is focus on is extracting the face. And sometimes that's the whole face, and sometimes it's the facial landmarks, which we consider to be things like the eyes, the corners of the mouth, the eyebrows, usually not so much the hairline, just because hairlines can differ so much from person to person, but these consistent features that occur on every humans. And as you can see here, Dom, like I imagine you actually cut out the face manually here.
It took me no time at all. I just used my two eyes and I was able to, within a matter of minutes, cut this face out. But I'm sure it's a little bit harder for the computer, right?
That is one amazing thing. Something that comes so naturally for us to draw a boundary around the face is actually took years and years in the computer world. And sometimes the algorithms are still a little rough, though they really have come a long way. But it just goes to show that how the computers function and how we function as humans can be very different.
Yeah. So if we talk about where it can first go wrong, it's that essentially isolation of the face that can create a bad result for a deepfake to begin with. But it also provides us, from the post-production side, a little bit of an advantage, right? So if we can have a isolated face or a masked out face that we can then start applying traditional post-production techniques to, we can actually improve that compositing result in the long run. So here we're going to start talking about how we'd actually do that. So what we've done here is we've taken our destination model at the top left. And what we've done is we've manually cut out the flesh tones of the face. And from there, we can build a lookup table by grabbing the highlights, midtones, and shadows from the face itself, as well as the whites and blacks in the scene. So we can then take that lookup table and we could apply it to our source model. So if you look over the bottom corner on the left, what you're seeing is our destination model's flesh tones compared with our source model. And you notice that they're wildly different. So we're never going to get a great result with that type of tonality. But what we can do is we can apply that LUT to our source model at that point and re-extract that isolated face to actually create a more realistic tonality of that skin. So that's the first way that we start improving it. When we saw in the previous example where the skin didn't blend correctly, well, why not blend all the skin from the start? So let's take a look at it. So here's an isolation, as we're talking about, of that source model's face next to our destination. And the skin tones, if you look way closer at this point, right? In fact, if we go ahead and we composite it for everybody to see, and we're going to zoom in so we're not hiding anything, it looks fairly realistic, right? Would you be fooled by that, Shannon?
I am fooled by it, and if you didn't tell me, I would definitely be fooled. But to me, it looks like it could be on the cover of a magazine of some celebrity I wasn't familiar with.
Yeah, but on the zoomed in version too, we can also see how it starts to break down, right? So if we're trying to fool a computer or a human, we can see ways that we can improve this image from right here. If we look at it again on the left, and we're looking at our destination, so that's the woman in the blue shirt, you will see that there's a shadow across 50% of her face, but you can see over here on the right, there's no shadow, right? So although it may fool you in this cropped in version, it may not fool you on her body because there is no shadow on that. So how do we rectify that? Well, one, we do it through motion tracking to make sure that we're actually tracking the image in the position correctly where it's going to appear. How does this work with the algorithm?
So it's pretty similar, actually. Again, so we mentioned those facial landmarks before, but the basic idea is that we want the facial landmarks to line up every single time and make sure that they're mapped consistently, and so you have continuous images over time.
Yeah, this works the same way for post-production. And we're doing the same thing. The only difference is in post-production, unlike the algorithms, we can use planar tracking. So we can actually be tracking not just the X to the Y, but also the Z of the image. And because of that, if the head turns or it moves around or the highlights are moving, we can actually isolate those and track those as well, which will create a more realistic result and less of that glued on sticker that you saw in the previous image, right? So if we look to here, it's like, okay, we've done our isolation tracking. We've positioned the head. It's positioned perfectly. And if we look at the one on the left, again, it's not a bad result. The skin tones are fairly close. And what I've done is I've purposely turned off the filtering, or I should say the feathering around the bounding box. So you can just kind of see, a clear definition of where it doesn't line up properly. But if you look at our image on the right, what you're seeing is, again, extracting the highlights from the destination, reapplying them onto the manipulated media. You're starting to see that shadow go on the face. You're starting to see the actual lighting effects in the background being integrated. And although, I'd say people still could look at this and say, well, it looks too perfect. It looks too rendered. So that would be my tip off. I think it's still fool a lot of people. What do you think, Shannon?
Yeah, I think if I was scrolling through, I would probably just say, okay, another picture and go on. But I have to ask Dom, how long did it take you to make something like this?
So with still imagery, it could take minutes to hours to do something like this. If it's full motion media, it may take, weeks to months, depending on how much effort I really want to put into fooling an audience. Now, here's the scary side of it, though. So just like when you train a model, and then that allows you to create deepfakes rapidly. If I train the pre-production pipeline or the post-production pipeline, I can then create highly realistic, photorealistic results fairly quickly as well. So if I put a lot of effort into this or in post-production, I can reuse that effort for multiple deepfakes at that point, as long as my source and destination material aren't changing. So I can make way more high-quality media than if this is a one-off. So I would say, now that we know about some of the post-production techniques on how to create deepfakes, I'm going to go ahead and give you a little bit of a test, Shannon. And we're going to go through these images and we're going to talk about why they fail and what should be easy indicators for this. So take a look at both these images, and can you tell me why you could easily tell that both of these are deepfakes?
The good news is I'm grateful that you let me have a peek at these beforehand, but honestly, my eye is not as good as yours when it comes to these, and I struggled. One thing I did see on these two images, to me, the hairline kind of looks kind of like more, the boundary is too distinct.
Yeah, I would say that's a good tip to start with. So the hairlines are always tricky, but I'd also point out that skin tone mismatching here. So if you look right along this model's face, you'll see that there's an obvious red line here. And essentially, we're seeing that difference in skin tone between the face replacement, and this, I'd consider this to be a face replacement because it's doing the eyebrows down to the chin. But I can draw a line directly around this, and I can clearly see that this skin tone doesn't match this skin tone. Now, our gentleman to the left, it's a little bit more difficult, right? Because it's all darker skin tones, and there's actually a highlight of white, from the light on top of the subject itself. But if I look carefully, I can see a very distinct line that goes across the forehead. And if I take that line, I can say, okay, this is a face replacement as well, because if I trace it, it's going right around to the chin, and I can see that difference in color from here to here. That's not natural. So let's take a look at another example. So what do you think, Shannon? This one's a little easier, right?
Yeah, this one I think I can figure out, because this person from the top looks very, very old, but the bottom of the face looks much younger.
That's right. Either his plastic surgeon hates him, or somebody didn't do a very good job of blending these two images together. So what you're seeing is the aging of the source and destination really come into play and making this an easy one to spot. But again, that's something that a computer could be looking for as well, right?
Yes, these are all things. So that's the challenge, right? So that's what we're trying to do.
Yeah, and again, it's all about learning how deepfakes fail when you create them as a way to tell these models what to look for. All right, this is a little bit more challenging, right?
Yeah, I found this one very hard, and only after knowing it's a deepfake, I was able to say, well, the faces are kind of blurry.
Yeah, the Kate Blanchett one in particular is pretty good. So what we're going to look at an easy way to figure this out, though. So we can look at how in focus those lines in the shirts are in, because these are two roughly blurry images. We wouldn't expect these lines to be as sharp as they are if the face is as blurred as it is. So that's the first tip off. The second tip off, again, if we talk about skin tone, particularly on this Kate Blanchett one that looks so well, we're seeing an obvious mismatch in tone from here to here. So again, this is another example of a face replacement where they're going and they're doing a decent job blending it. They probably use the algorithm and pick a skin tone that looks fairly close to what is in reality. But had they gone through that separate post-production task of actually creating a LUT, I bet this one would be indistinguishable and very difficult to put. This one's a little easier because you have this green tone here. But again, it's good enough that it might fool a lot of people. So start with the easy stuff. Look for things that are in focus that shouldn't be in focus if the face is out of focus. All right, we're going to get harder now. And we're going to talk about something, when you mix the art with the algorithm. So here's an example from Chris Yume. What do you think, Shannon?
Yeah, these Tom Cruise ones are really good. And again, this is really nitpicky, but after staring at this for quite a while, I was like, okay, maybe the chin area, the head and kind of looks connected to the neck in a 2D way. And maybe that's a little weird, but this is really good.
Yeah, I think this would fool nearly everybody, especially when it's full motion video. We've isolated a single frame. I would think that very few people would be able to pick up on that. But that's kind of where computers come into play, right? They can see the things that we can't. And if we look right at that neck there, we're seeing, again, that blurring that Shannon was talking about, where it almost looks like it goes right into it. But the other issues are, again, our fundamentals still hold true. What he's done here is he's hired a Tom Cruise impersonator with hairstyle just like Tom Cruise, wearing clothes that Tom Cruise would wear, roughly the same body shape. And he's then done a deep fake over top of it with his model. But the mismatch in skin tone still occurs. So the Tom Cruise here and the gap between where the mask is, and this is considered to be a whole face one because we're going all the way up here and all the way down here, still occurs. So you're still seeing that mismatch in skin tone right there. But you're also seeing the hairline, right? This guy has amazing hair that looks just like Tom Cruise's hair. And because of that, he wants to keep that as a media artist in focus, because then he could point to it and say, hey, this is one way to make it look more real. If we look very closely, we see that slight mismatching there, because it would take a lot of effort to painstakingly mask every frame of this where you wouldn't have that mismatch in color. But let's look at another example. So even experts don't always put the effort in on every frame, right?
Yeah, I think this
fake,
one
right?
we can figure out.
Yeah, we can. But here's the thing. This is a high motion clip. It's an individual running. I'd consider this to be a dynamic deepfake over a traditional deepfake. One, they're very hard to make. Multiple props to Chris for being able to do this. But second is, we see the faces in focus when the body's not in focus. And this is one of those indicators that we can really look for. I mean, there's not going to be many people that are going through high motion video frame by frame to isolate on an image. But this is something we can do, by creating a sequence of JPEGs and look at these images and say, okay, there's something wrong here, right, Shannon?
I would say so. That one part is way more in focus than the rest.
Yeah, so that's an easy thing for a computer to find, right? That one of these things doesn't belong, right?
Yes.
So let's talk about what we learned, right, Shannon?
Yeah. So fortunately, you've gotten to listen to Dom for a while now, but I've had at least a year now. And so I've learned quite a bit, but it's really knowing how to make these deepfakes and how we can better detect them. So Dom has pointed out some great features for us that we, on the technical side, need to use within our algorithms. And these are things that Dom mentioned, such as the blending, the color, the focus, the discontinuity in the mask, as Dom was saying. And then one thing that we didn't really talk about a lot today is some of the blinking.
Yeah, and you'll see the blinking. Either your subject will look like they never blink, which is a pretty good indicator, or just somebody that has maybe some challenges that we're not aware of. Or you'll see the eye kind of close 3/4 of a way down. And it looks like Shane might have a question for us.
Yeah, a question from John asking, is it harder to spot a deepfake image when watching a video rather than looking at a still?
I'll start, and I think Dom has some stuff to end on this, but I think this is a very interesting question. I think overall, a still is easier to fool someone, but at the same time, like Dom was saying, like these frames go so fast. I'm not going to check every single frame to make sure the video is correct. So, what would you say, Dom?
Yeah, I would agree with you. I would say the stills are a lower barrier of entry for most manipulators. And I would think that it's easier to create a high quality still than it is to create high quality motion video. At the same time, there are techniques that can be employed by degrading the video, adding different filters, putting different overlays on that can be used as distractors to manipulate you from seeing those very easy things that you could see if you just slow it down. So it's a challenge both ways. It's hard to detect, I would say, from a computer's perspective, the full motion video, because there's a lot more that has to go through. So I'm sure the algorithms show positives and negatives on the same image and have to have a correlation score to say whether or not it believes it's real or fake. Where an image, it can basically look at it and give you a determining factor score on that.
Right. There's a lot of computational costs in there. So thank you. That's a great question. And what we do know is that people can be really good at picking out deepfakes. And hopefully that'll continue for at least a little bit longer now. But we also know that there's so much video being uploaded to the internet every single day that we Dom and I, even though we do our best to watch as much video consumption as we can, we cannot rely on just ourselves for expert human detection. So it's important for us to be able to convert all these things that Dom just talked about into a computer representation. Okay, so here's the slide. This is the slide we in the machine learning field and statistics field kind of put up, and it's mostly just to intimidate people. So please, if you're not a technical person, please don't worry. We're going to try and break this down in a way that hopefully makes some sense. But basically, this is the idea of the so-called machine learning. And what we're trying to do is that we feed in inputs to our models. And so inputs, like we as a human here, what I'm seeing is like I see Dom's face, I see the slides and so on. So I would consider those the features. The inputs that we're giving the model are something a little different. And so we're going to give them these videos, and videos can be broken down into the following format. Videos are composed of single frames, a whole series of them, and each frame, it has, we're going to assume some set width of pixels and some set height. And then we have 3 channel values. Those would be the RGB. So you put it all together, that's everything that makes up a video. And I do hear we have a question.
Yeah, from Eric was asking, what are your thoughts on resolution, 400p versus HD versus 4K of the image/video and the ability to detect deepfake images?
Okay, so once again, I'll start. But I would say the 4K is a lot harder to make something that is going to fool a human, because that's a lot you have to worry about. But in the perspective of an algorithm, we do have trouble training some of these models on very large data, just because it's more than our machine can handle sometimes.
Yeah, I would say the technology has changed quickly when it comes to deepfakes. So when we first started our research, 480p was really the most prevalent version of deepfakes up there, because it takes a lot of compute processing power to create these. And you saw a big jump up to HD recently over the last year to 2 years. So when we evaluate our data sets, they're typically comprised of mostly 480 and HD. But we've done research with the SCI where we've gone through and create the 4K ones. Now there's challenges to creating 4K data sets. So namely the amount of file size that you have to deal with and how long it takes to process it, and the GPU's ability to take a batch size sufficient to train a model quickly. So when it comes to being able to detect them, I would say a lot of the 480 ones actually are kind of easy to detect because they break down fairly quickly. What you see, though, is on the 4K ones, they're typically by the individuals that have spent more time and more effort and have more sophistication in creating deepfakes. So ultimately, they may have a much higher quality than you would expect from a traditional data set. Do you agree with that, Shannon?
I do. And again, great question. Thanks for keep them coming. And while we do that, wait for your questions, we go back to this lovely neural net here. And so we talked about the inputs, and then on the other hand, you have the outputs. Those are probably the easiest to explain. This is something that we're just asking the machine, do you think this is a real image or a fake image? So it's going to give us some score between 0 and 1. And if it's close to 1, we're going to assign it as a fake. And if it's close to 0, we're going to assign it as real. So I have skipped over all the purple things going on in the middle, and that's where all the complex computations are occurring in the neural net. And we mysteriously call these hidden layers. But this is, you can think of this is, so we as humans see our own little fingerprints, and this is where the computer is trying to find its digital fingerprints. This is where it's trying to learn in a way what is going on, what makes an image a deepfake, but they do see it in very different ways than we do. So these are kind of two extremes, and there is a middle that we can do where we can help the computer give it places where we know to look, all those things that Dom talked about before, the blending, the color, the saturation, all that. So the end of this is that we get a ton of different methods with a ton of different transformations, like pull out the face, pull out the eyes, or so on. And what we need to do is we need to compare all these results. So what we said is, well, we need a pipeline. And neural nets, they can do really great when testing on in-distribution data. So this is the results from our pipeline. So when you train and test on something in distribution, what I mean by that is, say Dom and I are having this conversation right now, and we have this particular background. If Dom and I have a conversation tomorrow and we're still in the same place, I would probably consider something like that to be in distribution data. Now, if I were near a beach, and if Dom were on Mars, for example, then I would consider that to be out of distribution data. So this would be data that our model, our neural net, hadn't really seen before and is mostly kind of just guessing. So it doesn't know what to do with that sort of data. So what we see with neural nets typically is that they can do very, very well on in-distribution data. And we see that in this table here, where on the in the first column, we have the data sets that we trained it on. And then on the first row is going to be also the same data sets again, but we're actually using different test data. So you can see if we train and test on the same one, that's going to be the main diagonal highlighted in the yellows there, we do extremely well. So that's the power of the neural net. That's why they're so popular. But we can also see that if we go off the diagonal, we're going to suffer greatly in terms of performance. And this is why we really need humans to point us towards useful features in these detector algorithms, and why we need to compare them. So back to the pipeline. We need a pipeline, and that's what we've been working on here at the SEI. So kind of just to put it out for everyone, what we're kind of doing, and this is just one example, is that we're going to put an image into our detector. Here's a single still image. This one happens to be from Style Again 2. It is a deepfake. And for example, say there are some algorithms that focus on the mouse and say, okay, mouse are very different. So we're going to first do a transform. And in this case, we're going to extract the mouths of all the people. And then we're going to train our classifier just using those mouths, which is some sort of standardization. And then finally, we're going to evaluate them because we need to know how good we're doing. That is important. We can have our model output all sorts of things, but if it doesn't correspond to reality, then we're not really doing anything useful. So there are many ways. Well, actually just two. There are two ways we can be correct, and those are the true positives and the true negative. So what we mean by that, to really just break that down, is if the image is classified as a fake, and the image is in reality a fake, then our detector did great, and that's going to be a true positive. At the same time, if our image is classified as real, and it is indeed real, once again, our detector succeeded, and that is going to be a true negative. But I think what's kind of more interesting is the ways that we can be wrong. And so to really break this down again, if we classify an image as real, but the image is actually fake, that's going to be a false negative. And I want you to kind of think about that for a second, because it's kind of interesting. And then on the other hand, if we classify an image as fake when it's actually real, then that's going to be a false positive. And Dom, can you consider like how these false positives and false negatives can kind of be different from each other and make people think different things?
Yeah, I would say the media literacy impact on both the false positive and false negative are very impactful to the audience. So if I'm watching a piece of media and I identify it as being real, but it's actually fake, it's very impactful to me. But it's just as impactful if I look at a piece of media and I feel like I can't trust it, like it's some type of misinformation campaign, right? At that point, then I don't know what I'm watching is real or fake. And it's a real struggle, I would think, for most consumers. What do you think?
Yeah, it is. It can really depend on the situation. Oh, what is worse? I mean, false negatives can be really bad. It's like, oh, we should have actually listened to this thing or should have believed it, and we didn't at all. Usually from like an analyst point of view, sometimes the false positives can be worse, because then we're looking at something that we shouldn't have been spending time on. It was real, and we were kind of wasting our time because we're not looking at the things we should be, which are the fakes. So we do have to plug our work, what Dom and I and our team have been working on at the SEI. So we have and are developing this Deepfake Detection Pipeline, which we call the DDP. And it's an end-to-end process where we take in different data. We send that data along with any sorts of different methods and all sorts of different methods, from PyTorch, TensorFlow. You can do that. In between, there's some data pre-processing and transformation. So if you want to extract facial landmarks or do a Fourier transform, you can do all that. So we like to say that it's a plug and play detector. And then finally, we output the results in useful ways, which include example images, so we can actually see what's being classified as fake or not, as well as evaluation tools such as accuracy or the true positive rate or the true negative rate. One thing we do have to give a shout out to is that DDP's backend is SEI's Juneberry, and Juneberry is a publicly accessible tool. It's available on GitHub, and it has been incredibly useful for us to be able to standardize a lot of these methods. And we're hoping that this is a way that will more easily be able to put different data and methods side by side to compare.
Yeah, and I just want to give us another plug too. So I realize this conversation is a little bit more of a high level today, but if you're looking for that low level conversation to get more into the weeds with this type of detection methods, how deepfakes are created, again, reach out to the SCI about how you can sign up for our deepfake days that are in a couple of weeks, right, Shannon?
Yep, August 30th.
August 30th. So again, if you're looking for more detailed information, that's going to be the place to get it.
All right. So I think that brings us to the kind of a lot of what's ongoing. And then we want to talk kind of about the future of deepfakes. So we know deepfakes are getting better and better. And one of those reasons is why and how are they getting better so quickly? And this is something that keeps me up at night sometimes, and that is the ever-present threat of generative adversarial models or networks. Usually they're known as GANs, GANS. And GANs are kind of interesting. So it's basically you get to play a game, one of those mathematical games, and you have two players in this game. So you have one person is going to play the role of the discriminator. You can also say that's the detector. And then you have the other person who's going to be the generator. So we usually consider the generator to be our adversary. But so there's a lot going underneath GANs, but what the main high level point is that adversaries can directly use the results of our detector to make improved images that to make the fakes even better. So just by the mere fact that we're making a detector and releasing it, and we don't even have to release like the details of the detector of how we did it, just the results, then our adversaries can use our tool against us, which is certainly kind of frustrating, don't you think, Dom?
Yeah, it's like Groundhog's Day, right? So essentially, we make a better detector, which makes better deepfakes. So it's like we're reliving that same day over and over again. But it's not like we can get away from making the detector, because obviously we need to be able to give people a way to determine if the media that they're consuming is real and authentic. At the same time, we're helping the adversaries every time we make an advancement, right?
Yeah, every time we put something out there, but it keeps us on our toes. We always have to do the best. And this is an open field. There's a lot of interesting research questions. So if you also want to get in touch with us about any of these, please let us know. But this is kind of one of the interesting quirks of deepfakes. So in closing, yes, deepfakes are modern day lies, but we still think you should care because they are scalable and automated. As Dom went through in detail, they are an art and are improved when you have a human working with them. We know, however, that they greatly benefit from computer assistance. And then finally, better detectors can directly lead to better generators, leading to this multi-round game. We're trying to figure out where exactly that game will end. So, and Dom, I'll let you end with our final slide.
Yeah, so we thought this might be fun, since you've kind of gone through as an audience and you learned how to actually identify deepfakes and where they break down. We just want to see if our score goes up a little bit higher. So you got A, B, or C, all lovely examples, but only one of them is actually a deepfake. So we're hoping that while you're thinking about any last questions that you may have for Shannon or myself, you go ahead and put that letter into the chat and we can see how you all do. So again, A, B, or C. And Shane, I'll ask you if we have any final questions.
We do have a question from D. Rand asking, is the CFO image directing a money transfer real?
So is that the one from the swindling, the article?
I believe so.
So I don't know if it's ever been fully authenticated as a piece of deepfake audio. It's more hearsay, right? Because it wasn't recorded. So essentially, the CEO of the company received the phone message, and that phone message directed them to release a certain amount of funding. And because of that, they were fooled into doing it. The idea is that synthetic voice was used for that manipulation. Although it's not 100% confirmed, I think that's what most people are attributing that breach in security. Do you agree with that, Shannon?
It goes back to what we were saying before. Sometimes it's the deep fake, and sometimes these other things like Dom, you called it distorted media. I've also heard them called shallow fakes, which I don't think gives it enough credit. But the idea is, well, if the result is the same, does it really matter how they did it? We need to figure out either way.
Yeah, and I always call it like, I love to coin the term lazy fakes, because it's a lot less effort to do the traditional Hollywood style one than training the neural network, but the results aren't exactly equal at this point. I mean, the technology is progressing and getting so much better every year. I mean, 2 years ago, I didn't think that there would even be a possibility of individuals being fooled, but I think there was a recent issue with Mayor Klitschko being represented and fooling a large number of individuals through a live version of deepfaking called, I think, Deepfakes Live. So what we're seeing is the technology is advancing at a rapid pace. So our detectors that we're building have to keep pace with that. Right, Shannon?
Yep, and add the GAN problem on top of that, and that keeps us pretty busy.
Yeah. So do we have any results, Shane?
So we got a pretty even mix. We had 2 for A, 4 for B, and 3 for C.
So we may have to ask people to rewatch a little bit again, because if we look, our answer is, drumroll please, A. And the
Yeah.
reason behind that is this blurring of the face right here, right?
That's the main one. And the other is that kind of looks like a chair behind our fake person there. It's not really a chair. So that's another tip off there. But if you're not looking for it, it's hard to spot.
Yeah, that's a great example. The background that we see here, the fact that we have this black edging here, these non-organic shapes, the lines that don't meet up on the background. When you're looking at these GAN generated images, they can be tricky. Luckily, we didn't show you any of the ones that haunt our dreams, like the two-headed monsters that we're so used to seeing.
There are some frightening pictures that Dom and I have to look at. Just like people's heads end up stitched together with the deepfake and that sort of thing. That's a little creepy.
Yeah. Well, unless there's any more questions, Shane, I think we can go ahead and end.
No, I don't. No questions. We can wait just a second for someone to type one in, but so I'll just kind of start to wrap up now in case somebody types one in. But I wanted to thank you and Shannon for your great discussion today and sharing your expertise. Really, really good stuff.
Glad to
and
be
I'm
here,
going to thank everyone for attending today. Upon exiting, we do if you hit that like button below the video window, and then you share the archive if you found value. Also, you can subscribe to the SEI YouTube channel by clicking on the SEI seal in the lower right corner of the video window. And for our next webcast, we're looking at, I believe, September 20th. We're going to have a Carol Smith and Mike Matterock with an AI engineering topic, both from our AI engineering division. So let me go back to our questions, see if anything in the meantime. No, just a couple comments about a comment from Bob saying neural net faces tend to do slightly weird things with earrings and eyeglasses. Similar experience for you too?
Yeah, we've seen that a lot. The asymmetry in the deepfakes is a huge tip off for us right now. That you'll get a stud on one side and a hoop on the other, and you're like, well, that's not too common. So it's definitely a nice tip off. So sometimes when the algorithms give us like freebies like those, we're very grateful. So we're hoping the GAN doesn't take those away from us too soon.
Yeah, I think there's a lot of enjoyment that comes out of that. In fact, I know there's a lot of individuals who use the DALL-E 2 platform or other platforms like Crayon for generating all these images. I think John Oliver recently did an expose on it where you can create some really realistic images, but also some really wacky ones at the same time, right?
Great. Thanks again for the presentation. I did add the URL for Deepfake Days in DC here. So the registration link is in the chat for anybody interested in that.
Thank you.
And that's it, folks. Thanks again. Share the archive and have a great day, everyone. Thank you.